Welcome to FYI, the 4-Year Innovation Podcast. This show offers an intellectual discussion on technologically enabled disruption, because investing in innovation starts with understanding it. To learn more, visit arc-invest.com.
ARC Invest is a registered investment advisor focused on investing in disruptive innovation. This podcast is for informational purposes only and should not be relied upon as a basis for investment decisions. It does not constitute, either explicitly or implicitly, any provision of services or products by ARC. All statements made regarding companies or securities are strictly beliefs and points of view held by ARC or podcast guests, and are not endorsements or recommendations by ARC to buy, sell, or hold any security. Clients of ARC Investment Management may maintain positions in the securities discussed in this podcast.
Hi there, I'm Nemo, a multiomics analyst at ARC. And welcome back to our FYI podcast for your innovation. Today, I'm joined by my colleague, Dr. Charlie Roberts, Chief Investigator and Head of the Venture Fund at ARC, and Professor Michael Snyder, Chair of Genetics and Director of Genomics in Personalized Medicine at Stanford. In addition to his very productive and successful academic career, Professor Snyder has also co-founded companies in genomics, genetics, and personalized medicine space, such as Personalis, January AI, Omics, and QBio. Welcome, Professor Snyder. And so maybe just to kind of kick it off, this conversation, how did you actually got interested in genetics, genomics, and what were some pivotal moments in your scientific career?
Sure. Well, I guess if you go way back, I had an amazing chemistry teacher in high school that probably got me interested in science. Not sure I was terribly interested in science before that, maybe always a curious person. Then I went off to college and majored in chemistry and biology, and then later went to graduate school, and just have always been interested in science, I guess. And I certainly love what I do. I think at the time I did my graduate work, people used to study genes one at a time. And so I think I always thought that was very cumbersome way to learn things. And so I think where we really made our mark is when I launched my own career and then started studying basically, all the genes at once, in that case in yeast. And so it really launched the field of systems biology. I think that was the key moment for us. And we then studied things at a systems level. I moved to Stanford 15 years ago, and with the idea of bringing some of these we'd been inventing technologies, but bringing some of these same things to medicine. And so really launched the field of systems medicine, the idea of getting more complete pictures when you profile people with big data versus what we currently do, which is pretty, if you think about it, antiquated in many different ways.
Great. I think, when I think about your research, to me, it really is kind of really the systems level connecting genomic variation with kind of phenotypic variation and really finding the causal relationship there. And how do you think that kind of your discoveries in your work in the discovering all this genomic variation actually is leading the charge in actually transforming the medicine to be more predictive and preventive today?
Yeah, well, genomics obviously is the blueprint for us in all aspects. I mean, your genome controls not just your physical appearance and a lot of your, disease propensities, but also your behavior and many other things. But it's not the whole equation. Your genome only accounts for 16% of your lifespan. So other factors are important too. So we really need to understand the whole shebang, if you will. So I'm a believer that for genomics, we need to understand the genome better, and we're a long ways from it, especially when it comes to the regulatory sequences that turn genes on and off and being able to make predictions about people's health from that. It turns out a lot of your health is probably influenced by gene regulation, not as much the genes themselves. So I think we need to learn a lot more. I think we're trying to push a lot of that very, very hard to identify all the variants that affect your genes and how they work, and then ultimately with the goal of making predictions about people's disease risk from that information. So I argue that in some areas we're pretty good. We can predict, for example, If you have a mutation in BRCA, one of these breast cancer genes, we have a pretty good idea for those kinds of mutations. But in most complex disease, we still have a long ways to go. So we've been pushing a lot of that. And it turns out this, AI, machine learning have turned out to be incredibly powerful for dissecting the genetics of genomes. So we've been pushing that pretty hard, and that seems to be working very, very well. In the case of ALS, very debilitating disease, there were 7 genes known. By traditional methods, we found 690 genes with our new AI method. So we think we can now get at the genetic basis of disease just much, much better than we used to be able to. And I hope that's going to ultimately lead to be able to predict what genes you're most likely to get so you can watch out for those things and take care and ideally catch disease early and treat it before it becomes symptomatic.
Could you unpick how the rest of if only 16% is governed by the genome, how the rest breaks down? Is that all pure behavioral choices? And if so, were some of those behavioral choices informed by the genome and the makeup of the genome, or is there some level of epigenetic inheritance and other factors at play? It'd be very interesting to unpick that rest of the prediction.
So the answer is definitely your lifestyle, your environmental exposures, these all influence and we don't have all this worked out, long ways to go. So an obvious case is, pathogen exposures. You may know if you get COVID, there's quite a large fraction of people wind up getting long COVID as a consequence. That's a classic case of, an epigenomics situation. The viral infection turns out an epigenetic effect, we think, in some cases. So that's a simple environmental exposure, pollution, things like that are all going to impact your health as well. But lifestyle is a big factor too. Your exercise, the food you eat. And there's some interesting studies now, especially in the area of exercise affecting the epigenetics of your DNA, actually directly modifying your DNA. So we don't fully understand how this works. It's a field that really needs a lot more investigation. But it's very, very clear that if we can start dissecting this, we really should be able to get people to better modify their lifestyles and such so they can actually, live longer, healthier lives. That is the goal. We'll use all this information, their lifestyle, their environmental exposures, their genetic risks, to be able to predict, what things they're most likely to be at risk for and how to modify their behavior. That's where I hope this whole field's going to go. It's going to take some time to get there, but we're getting there bits at a time.
Do you see that lifestyle factors and all of the other things, or lifestyle choices and all of the other things people are doing now, the craze towards lots more fasting and people taking metformin and different blends of diet and things, do you think that gets just a lot more people to that sort of hallowed 120-year limit? Or do you think some people will get way beyond that as a result of those interventions? And maybe additional to that, do you think there are other, maybe more fundamental interventions that are being developed now or already in hand that will enable people that live today to live way beyond that 120 limit? So it's kind of a compound question.
So I think we're going to need all of the above, meaning you are going to need to modify your lifestyle. Or lifestyle now is so much worse than it was previously, meaning people don't eat as well. They tend to eat much more processed food. They don't exercise as much as they should. So it's pretty clear people do need to modify their lifestyle. And the classic case is diabetes. In the US, 9% of people are diabetic, 33% are pre-diabetic. And those numbers are just going up and up and up. So we've really got to get people to modify their behavior. And that's a simple one. And I think the new technologies like continuous glucose monitoring, that's something we're doing a lot with in the lab, and we've spun off a company that actually uses continuous glucose monitoring. It's called January AI, and they actually incorporate this into a behavioral modification program so that people can modify their lifestyle, if you will. And if you wear one of these devices, by the way, they're really eye-opening. So continuous glucose monitors, for those of you who don't know, they measure your glucose every 5 minutes. And it turns out a lot of us have glucose dysregulation, don't even know it. And we all will respond differently to different foods. So some people will basically spike their glucose, if you will, in response to potatoes, others to bread, some to bananas, some to grapes. We're all different. And it's very personal. Our microbiome, coming back to a question you asked earlier, is a key factor in this. It's not the whole equation. It's part of the equation. But we need to figure out what foods spike us so that we can avoid those, if you will, and then get our glucose under control. And so those devices will help us modify our lifestyle. I think they'll help us get to be 120. I'm a believer you should be able to live forever, but it's going to take even more things like getting new stem cells in, and this is where new approaches people are working on should be able to do some of this. So there are rejuvenation methods out there. There are a lot of companies forming. They're mostly starting on the skin because that's an easier way to start and probably less deleterious. If you modify skin, you can make people have a young looking skin, if you will, for a while. People do that now. They even put toxins on their skin. Botox is a good example. So this is how these things start. And also some of these therapies, if you will, these anti-aging approaches, I should say, they're also taking on some disease situations. So one area to be excited about, for example, you may or may not know your mitochondria basically wear out. They pick up genetic mutations throughout your lifetime. And so there's no easy way to reverse that. Probably the easiest way is to replace your mitochondria. We'll need new technologies for that. And there are companies out there trying to do just that. So I think we're going to need a combination of new strategies if you really want to live forever, or at least past 120. And then you'll also need to, improve your lifestyle to keep yourself healthy during that whole time. You don't want to just live to be 200 and have the last 100 years be a disaster, a health disaster. We all want to live healthy lives and then just basically, bump off, if you will. That would be the ideal situation.
I just wanted actually to continue along those lines and talk a bit more about your kind of deep omics research and how we're actually connecting the kind of genomics with multiomics and then with phenomics to actually measure these things and kind of qualify what is a healthy state and then what is actually a sick state. Because I see that as a path actually kind of, leading us to that where the people are going to live much longer because I feel that today we don't even understand what is a healthy state for someone. We have these huge ranges, which are so not helpful, actually.
Our healthy state for all of us is different, meaning our baseline is very, very different. Our heart rate, resting heart rate's different, our blood oxygen, all these parameters are different from one person to the next. The key is to know what your healthy baseline is, and that's where this deep omics profiling you're talking about kicks in. So our shtick, if you will, is to collect deep data on people. And if you go to a physician's office today, they measure maybe 15 things, some of which are of questionable value. What we think is we should be measuring hundreds, if not thousands of things. And that's what we're doing in the lab. And that's what we've done to spin off companies. So meaning we'll actually measure as many molecules, we'll sequence people's DNA, make genetic predictions of risk. And then on top of that, we'll actually measure as many molecules out of blood, urine, even your microbiome, which are the bacteria in your gut, if you will, that show up in your poop. We measure those as well. They're very important. We know they're important for your health. It's not all figured out how to bring that in clinically just yet. But we make these very, very deep measurements on people. And we started a project basically actually about 14 years ago on me and about 11 years ago on a group of little over 100 people. And we've been profiling them with these deep data approaches, these omics approaches, where we'll measure all their RNA and their proteins, their metabolites out of their blood. And basically, from these deep profiles, what we've discovered is that we've been able to catch cases of disease before they had symptoms. So meaning from the first 109 people we were studying, just in the first 3.5 years, 49, nearly half of them learned something pretty about their health, all pre-symptomatically. Meaning we caught some people with, one person with early lymphoma, 2 people with pre-cancers that can convert to aggressive cancers, 2 people with serious heart issues, all before they had symptoms. They didn't know they had these issues. And then by these deep data profiles, we could see this. And so the way we like to think about it is if your health is a 1,000-piece jigsaw puzzle, we're trying to measure 600 or 700 pieces versus what we do today is more like, 6 or 7 pieces, where we just don't see this. And with this clear picture of your health, you can see when things are off. And then this company we spun off, QBio, they do a medical version. So what we're doing in the lab is trying to measure everything. We don't know what's going to be useful and what's not. But as we learn what's useful and what's not, we basically made medical version of this. This is this company, QBio, as they say. They do these deep biochemical, these omics measurements at some level But they also do whole body MRI. And same thing, they caught disease early, all pre-symptomatically in many, many cases, even caught early pancreatic cancer, one case, ovarian cancer, things that people had no idea. And if you catch this stuff early, you can actually treat it and cure them. But the problem is often these things are caught late after the cancer is spread, and then it's a disaster. It's almost impossible to reverse that. So that's the key. Do this deep data profiling on people while they're healthy with modern tools. And if I could add a little more, I know I'm rambling a little bit here, but when we first started sequencing genomes, most physicians freaked out. They really didn't like this idea because they said, look, you're going to discover all these disease risks. You're going to turn everybody into hypochondriacs. It's going to cost the system millions of dollars. And that turned out not to be true. Meaning, yes, you see these disease risks. People were able to incorporate the information. It wasn't millions of dollars, few follow-up tests in many cases. And we also caught disease early. We caught a very young guy. Turns out we sequenced his genome. He had a heart. We saw a mutation in the heart gene. Turns out he has a heart defect. He's on medications. It basically potentially saved his life by making this discovery. So they're warming up to this idea. They're not there yet for a whole body MRI, I can tell you that. Most physicians absolutely hate the idea of whole body MRI because they say, oh, look, you're going to find nodules. And it's true. Everybody has nodules. If you ask Mike Snyder, should we have whole body MRI? I'll say absolutely, because the issue is not whether you have nodules. The issue is you have growing nodules, and you get that by longitudinal profiling. So that's another key aspect. Don't just measure people, measure them over time.
If I'm understanding this correctly, it's many different measurements and doing that longitudinally, basically, and that's where is the kind of secret sauce. But I'm just kind of curious, and maybe if you can expand a bit on the QBio, how do you bring this as a product to the people, and just knowing how healthcare is actually resistant? I mean, even going to a whole genome that was sequenced in 2003, and how long does it actually take to bring the whole genome sequence in the clinic? How do we kind of go over that obstacle, and how the QBio is kind of working on that front?
The problem, especially in the US, is that the financial incentives aren't aligned, meaning the whole healthcare system's broken, to be perfectly honest. We treat people when they're ill rather than keep them healthy. And nobody pays to keep them healthy. And that's the part that has to shift around. Meaning, if you want to get probed while you're healthy, say with QBio, whatever, you have to pay out of pocket. So we don't have a system, especially in the US, very fragmented. Nobody's going to put a lot of money into you when 18 months later, that's the average time. 18 months later, you may shift to a whole new healthcare system. So why would I invest $10,000 into you if you're going to shift later? Now, I think as the cost of these technologies drop, like genome sequencing, it'll be $100 for the actual sequence. The interpretation will still be more. But as these get cheaper, then they can do it. But right now, it's fairly expensive. And also, we've got to get the incentives aligned. So I think we need to get one way that this is working is getting employers involved. A lot of large employers have wellness programs, at least in the US. And so this is one way to get people to do this. We haven't talked about wearables yet, but these are very, very powerful monitoring devices. And I think you should get a discount or get a bonus maybe from your employer if you wear a smartwatch, because they are actually tracking not just your fitness and whatever, they actually can track your health. That's one of the things that we showed, and happy to talk more about that. So I think we need to get this whole financial incentive reworked, because I think you can have people live longer, healthier lives. I think we can actually save money, and that's been demonstrated through simulations in certain areas like cardiovascular disease. If you actually sequence the people at risk, you might actually catch those who really are truly at risk and take better care of them ahead of time versus let them get a heart attack, which is super, super expensive, both on the hospital and long-term disability. So I think we need to realign the whole healthcare system to get people to stay healthy, give them financial bonuses. I also think you got to get family involved. I'm a believer only two things really motivate people, money and family. And if we can get both involved, you'll actually be able to help get us in the place we want to be, get people monitoring, keeping them healthy and happy.
Yeah, I really like your idea about, if you're wearing the Fitbit, you're getting actually some discount. I just even think if you could come to the stage where patients actually can monetize their own data, that would be similar like the kind of Facebook and those tech companies are actually monetizing our actions there. Why can't we do that for the healthcare where the patients are the beneficiaries of that actually?
Yeah, a great point. So maybe to back up a little bit, we're big believers and diving deeper that wearables are super, super powerful because they're measuring you 24/7. And that's one of the shticks, again, that we also like to think we had some strong influence on, meaning when these devices first came out, they're mostly fitness trackers. We realized they're pretty powerful health monitors. We put them on our group. And you can see I'm a big believer. I don't know if you can see this, but I got my 3 smartwatches, my ring, even my hearing aid. I use it for hearing, but it's also a sensor as well. Really, it measures things. And so these devices are powerful because they're measuring you 24/7. Resting heart rate turns out to be a very, very important health monitor. Something called heart rate variability is a big, important health monitor. And they'll measure way more than that. They'll measure your blood oxygen, not accurately, but good enough to see shifts. And that's the key, seeing shifts. We put too much emphasis on absolute value. It's really the deltas that count. When you shift from your healthy baseline, you want to catch that. And wearables are powerful because they can do just that. The continuous glucose monitors I mentioned earlier, they're super powerful for that. They're following you, looking for shifts. So anyway, we discovered early on, and in fact through me, that you can tell when somebody's getting ill from a simple smartwatch. Because what happens is your resting heart rate shifts. In my case, I figured out my Lyme disease of all things pre-symptomatically, meaning I saw my resting heart rate go up. I also saw my blood oxygen drop before I had symptoms. I knew something was off. And then we figured out it was Lyme disease. I sort of suspected it was because 2 weeks earlier I'd been in a very Lyme infested area. And then we went on to show that we could pick up when people are getting respiratory viral infections from a simple smartwatch. And it's a very, very sensitive measure. We published this in 2017. Then, of course, along came COVID in early 2020 here in the US. And basically, what we found is that we could pick up COVID. COVID has a long pre-symptomatic period. It turns out it's very easy to pick up with a smartwatch. We can find it 80% of the time, a median of 3 days prior to symptom onset, at least by a real-time alerting system. So to dive a little deeper, we built a cloud-based system that can track millions of people. And if you sign up in our study, you actually can basically get yourself monitored and you check and you see whether you have an abnormal, it's mostly resting heart rate, an abnormal signal from your smartwatch. And it doesn't mean it's COVID. It could be other things, but it means there's some sort of stressor going on. Often it's COVID. It could be other things like influenza viruses, things like this. And by the way, these go off pre-symptomatically. And it also turns out it could be mental health stress as well. So workplace stress can be a big trigger of this as well. So anyway, these can measure not just physical stress like from respiratory viral infections, but they can measure mental health. And I know if we bring in different data types, we'll be able to distinguish those. Right now, we can't. That's why we're still running more studies. But bottom line is these are very, very powerful health monitors. Again, not just for physical health. We think they're going to be powerful for mental health. And so we'd like to see these roll into the mainstream. And getting back to the point you raised earlier, I just think, we should be giving people bonuses from their either provider or whatever if they wear these devices, because I think they're going to make them keep themselves healthier if they do.
Thanks, Michael. That's super interesting. And maybe just to double click or encapsulate and concentrate around one core theme that builds off what you said. What do you think, as you think about what might be a coming iPhone moment, or I guess we might now say a ChatGPT moment in longitudinal personalized health? What do you think that looks like, and when might that come? That there's a real tipping point, and really, this is not just early adopters, going very deep into the data like yourself and those following you, but really becomes something that many or most people are doing really at scale, and it's really affecting their lives. What do you think that might look like, and when do you think that might land?
It's always hard to predict these things, but I think it'll roll out gradually. I think it'll start with the wearables because they are fairly inexpensive. Even a $100 smartwatch can do everything I just said, detect COVID, etc. So I think they can roll out that way. But I think The key is that get the financial incentives aligned, because otherwise you won't get people to do it. So when that happens, I don't know. Right now, it's just going to be the motivated, the worried well, if you will, who want to live, or just optimizers. I guess is better. People want to live long, healthy lives, will adopt this stuff quickly, tell their friends it'll go that way, but it's not going to roll out at the speed I'd like it to. I think you need some sort of financial incentive to get it out there. And I don't know how long that's going to take. It could happen in a few years, could take 5 years, 10 years. I think it will become commonplace in the future. The analogy I like to use is your car. All cars have a dashboard. You wouldn't drive your car without a dashboard. You need your speedometer. You need your gas gauge. You need that check engine light to tell you when something's off. And I think health monitoring is going to hit that same point at some point, meaning why would you go around and not want to monitor your health and see when things are shifting early so that you could take advantage of that information? Maybe if you are getting ill, the obvious thing to do is, stay home and not infect other people. Or if it's COVID, and you're high risk, maybe take Paxlovid, which will help you. And same could be true for, taking Tamiflu or one of these other things if it's influenza. So I think we can use this information in a very beneficial fashion. I just think we again, maybe if we either have to educate people, if it's going to be like the car dashboard, but it'll move faster if there are financial incentives. And I honestly think we could put you may or may not realize, but half the planet has a smartphone. Okay. Even in poor areas, people have smartphones because they're still connected. Might be a little spotty connection, but they're still connected. And if you pair that with a smartwatch, you actually have a monitoring system for half the planet, not only for their personal health, but also for global health, meaning if an endemic or pandemic starts in a location, you actually could monitor that real time. Now, this might relate to Nemo's comment about privacy and things like that, about data going to companies, and that those are other issues. I'm a believer, we should have laws to protect ourselves so nobody gets abused by their health information. We do at some level, something called a GINA Act, so you can't be discriminated based on your genome sequence for employment or health plans. Although we need a broader version of that for health monitoring. And to be honest, if people share their data, we actually can learn a lot more. Meaning, like I was mentioning before, if people were to share more of their smartwatch data, we could tell the difference between mental health stress, meaning workplace stress, versus a respiratory viral infection. I'm quite confident of that. We just need to pull in more data types. So if nobody shares their data, of course, you'll never be able to do that.
Just turning our thoughts to how you're using AI, it'd be very interesting to get some insights into, obviously, the pure N of few hundred people is obviously very low. Obviously, that's the power to make inference is then improved by having all these high frequency measurements. How do you think, as the pure N goes up into the thousands, maybe the tens of thousands, maybe even eventually the millions, how do you think that will actually change the insights? And, it'd be very interesting to understand what you think about the trajectory of the learnings from that. And also if you've been able to use any auto-regressive kind of training along the lines of what happens in large language models in order to inform the models and maybe use bigger models using all of these sequential measurements.
AI is going to be totally embedded in this in many different ways. I mentioned we have new ways of analyzing genomes with AI, so that's on the research side. But believe it or not, we actually can, from a smartwatch, predict clinical measurements using AI, meaning we take features from a smartwatch and predict, for example, your hemoglobin levels and other sorts of things as well. Even your skin dryness, which can be a measure of diabetes, if you will, but you bring in other factors. So we can get some level of clinical measurements from a simple smartwatch, and that's all done with AI. And then to your point, we can also build personalized AI tools. I mean, you can now collect enough data around a single individual. We do around me. I've been measuring myself for so long. I have these personal AI programs that can tell when I shift and what most likely that shift is due to. This company I'm involved with called January AI, they actually can predict your glucose levels. They get 4 days of training from a CGM, continuous glucose monitor. They also bring in heart rate, and then they can actually predict your glucose levels, period, meaning without a CGM in the future, because, and they use a smartwatch and other parameters. And in that case, they also have a 32 million food database. They can make recommendations. They're not just predicting what's going to happen, but they also have a whole recommendation system. And I think that's the future. I just think everything we do, this is good for you, this is bad for you, it just modify your lifestyle in ways that won't be too just, inconvenient, meaning eat the foods you like that are good for you and you still like, and avoid those that are bad for you, and shift your lifestyle. And I think that'll help reach that 120 we talked about earlier. And I think we need that. There's also other behavioral modification things, like exercise is a little trickier to get people to do. But if you ever wear a continuous glucose monitor, you'll see they're very, very motivating. And for example, one of the things that January AI does is they actually have you, they tell you to eat your favorite food, which almost always is sugar and spikes you, it spikes your glucose. And then they'll say next day, eat your favorite food and do a brisk 15-minute walk. And you'll see that spike gets very, very suppressed. So it's a way of teaching people to, live better. And so I think more of those things, especially it's very visual, it very, very much hits you in the face that this is a pretty good thing to do. And I think we'll have more and more of that. We'll learn how to bring this in. I think then you brought up another issue about LLM kinds of models and things for AI as well. I think that will feed back into the user. We are doing some of that with some of my other companies. January is doing it, as is another company we're involved with, YOLO. It's called IOLLO. They actually will do, we didn't talk about this, we can now do remote monitoring where you take a little prick of blood, mail it in. In the lab, we'll measure 2,200 molecules. This company, YOLO, actually measures over 500 molecules spanning over 20 different health areas, meaning inflammation, oxidative stress, kidney. And you can do it all at home, meaning you take the drop of blood, you mail it in, and we give you back a report. And they use AI to basically collect that information from the report, integrate it with others, and give a report back. All right, this is your profile. If you modify your behaviors, you can improve this part. And, you're doing great on that part. Keep it up. This part, you could use some improvement on. Maybe your inflammation's high. Here are the following 5 things you should do based on what your current lifestyle is. So I think this is how the world will work in the future. And it has to work that way because physicians right now, they just don't have enough time to spend with you. They get 15 minutes with you. And in some parts of the world, they only get 3 minutes with you. And so whereas you yourself have more time to spend on you than anyone else, and so pulling in information, getting recommendations from others, and this is where AI kicks in, it's not going to replace doctors, by the way. It's simply going to augment what they can do. And some people like to say, who would you rather be seen by? A doctor who uses AI versus one who doesn't. I think most of us would want the one who's pulling in as much information as possible, scrutinizing it to make sure it's accurate, because you obviously have to watch out for that. And then, making recommendations based on that information. So those are some of my thoughts there about AI, but it's going to be totally embedded in the system.
Do you think, there is so much different data that we can collect, phenomics, multi-kinomics, is there going to be we want everything, or do we want to kind of some longitudinal measuring of the kind of phenomics and then certain markers in the multiomics? How did there was a study from Stanford a few years ago about becoming an immune age, where they show that measuring the immune markers, that kind of shows your true biological age versus just the number of years. And so how do you see combining all of that together?
Let's start with the data in general. So we don't know right now what all the best data to collect are, but we know it's more than what we're doing now. And certainly these profiles give us a lot of information, bring it in. And it is information overload for the average person, right? You get all these measurements and what do you do with that? But I think much like your car, in the future, that information will get integrated into use full packages. And QBio is a good example. They return the information in a very organized fashion, which the healthcare system doesn't do now. If you ever look at a report you get back, if you ever looked at your health record, the information's scattered. It's a mess. Whereas, it could be better organized. And then, maximally, we can integrate information better. And again, I'll go back to the car dashboard. Your check engine light, means one of a number of sensors is off. An average race car has 400 sensors on it, or probably more now. And nobody's staring at all 400. They're integrating the information, relaying it back to the dashboard so you can figure out, something's off and then dive deeper if you need to. I think that's how health monitoring is going to work in the future. You might get a cardiovascular light that goes off, and then you dive in a little deeper and see, well, what's that due to? It might be due to A, B, or C. And this is what you should do about it, X, Y, and Z based on that information. So I think this is how things will roll out in the future. But you're right. And the average person just can't understand that, even the average physician. Another analogy I can use is a pathology report, right? When they look for cancer and they do sectioning and they're looking for, cancerous material, most doctors don't know how to interpret that, but pathologists do. So they look at it, they interpret it. These days you would do it with AI. You would actually use image analysis software to see whether it's likely to be cancer and what kind. But anyway, these days it's mostly done by a pathologist who writes a report and sends that back to the physician. So it's a summary of what's going on. So that's how I see this rolling out. That yes, we'll collect way more information than we do now, and then it gets distilled into a useful fashion that people can act on both at the individual level and also at the physician level. And I do think, back to the comment you made earlier, I do think that measuring, putting a lot more power back to the person is a big deal, because they can spend the most time figuring out what's going on. And you can do all that. We built dashboards, for example, on our smartphone that can pull in your health information display in a very simple fashion for the average person. I think your smartphone will become your most important health device in the future.
Yeah, I actually have two follow-up questions. You mentioned pathology there, and maybe kind of good segue to talk a bit about the Human Spatial Atlas, and how do you see that initiative, and how do you see methods as spatial actually replacing pathology today? Because going back to pathology, I feel there is so much data in that slides, and we will follow one or two markers. It's very subjective. And so that's one axis. And then the other one, kind of keep going back still with the data. And this is something that from what I understand, originated from your lab, is the Deep Data Research Computing Center at Stanford. And, what's the kind of aim with that center, and kind of when it comes to what kind of data is it? Like, let's collect all the data that we can and see, how can we make the best use of it?
So going to the Human Cell Atlas, maybe that's a project to map all the cells in the human body, if you will, at single cell resolution, meaning know where every cell is and what its state looks like. That's the goal, an incredibly detailed map. But right now, there's a program called HubMap to do this in healthy tissue. And then, of course, you'd like to do it in disease, and there are programs rolling that out. There's something called the Human Tumor Atlas Network that's doing it for early stage cancer. And so the goals there are to see what are some of the earliest events. First of all, what does a normal map look like? There's a lot of discoveries going on there from our lab and many others. They're going to do it for every organ in the body. And then in the cancer, what are some of the earliest changes that are occurring? That's what people are very interested in. And then how to use that information to protect yourself from getting cancer, and also treating cancer. And there's a fact many people probably don't realize, but we're loaded with cancer cells in our body, millions of them, okay, all throughout our body. And that's basically a relatively recent discovery. Now, most of the time, it doesn't cause cancer, probably for two reasons. When it breaks out, your immune system clears it. And in other cases, it's something called the microenvironment. The environment those cancer cells are in keep those cells from growing, the combination of the two. These maps are going to be, we think, very valuable for trying to understand that. What is special about that microenvironment that's keeping that cancer from growing? And so we need to work all that out. And that's what we think will come out of this. And then ultimately, that information we hope will be useful for keeping all these cancer cells in check so that you don't get, the cancer breaking out. And it becomes a big deal. Your immune system starts plummeting in the 60s, mid 60s especially. And what will happen is then there's a greater chance that, this cancer will break away. And that's one of the reasons why cancer does appear a lot more later in life. Your immune system is not as robust as it was, when you're 20. So I think the more we can understand, how to keep cancer in check, the better we can deal with it, especially when our immune system starts maybe not up. It's not as optimal as it was when we were younger.
And do you think that there will be like the spatial could actually replace one day how it's being done today, spatial methods?
I think it will be done better. First of all, we're going to use AI. We're going to use image analysis. It still surprises me we don't. And I can tell you right now, there's plenty of papers out there that show image analysis software is much more accurate than physician diagnostics. So I think we need to bring that in. And then adding in these higher stains, as you point out, they're using more probes to look at cells and get higher information content using these modern tools will definitely be powerful, especially for discovering, like deciding which ones are malignant, how aggressive our cancer is going to be. You should be able to predict that from all these markers. And then usually what happens is discovery is done with lots and lots of data. And then you take the most useful data to keep the tests inexpensive and use those to actually set up a specific diagnostic test. So even though we'll be probing for hundreds, if not thousands of gene expressions in every cell to understand, cancerous tissue, at the end of the day, my guess is maybe if 100 or a few hundred probes will be enough to say, aha, you have this kind of cancer. Here's what it's likely to be in terms of its aggressiveness. And then here's the recommended treatment based on that information. So I don't know if that makes sense. This idea of collect a lot of data to best understand and to use the subset that can most be used for therapeutics and treatment.
It does make sense thinking about the time. And so maybe the last question, what are the kind of biggest three frontiers that you see in healthcare, biomedicine on horizon that will be changing, as you're saying, the sick care to the healthcare?
Yeah, I think two things. One is the remote monitoring I mentioned with the wearables and this microsampling that we touched on, this idea of doing frequent monitoring at home. And I just think that's going to transform the way we do things, because going to the physician, people just don't do it very often. The measurements you get there, they're very few and not that accurate. So I think that's going to be very, very transformative. I think this idea of longitudinal monitoring, building personalized tracking systems for people that will be, with AI engines around them to track people's health is going to be a no-brainer as well. It's amazing we don't even do that physicians rarely look back at previous data. They just look at the last measurement. So I think these longitudinal tracking systems will be powerful. And I guess underlying all of this is the amount of data we collect will just be way, way more than what we currently do. And I think that's just going to help us measure what's going on and, lead us to healthier, longer, happy lives.
Great. Maybe just a quick one more follow-up question. Do you see any of the measurements that we have unmet need that we can't collect the right data on the multiomic kind of spectrum? In my mind, proteomics is always lagging behind the kind of DNA, RNA, and the kind of epigenome to a certain degree. So how do you feel about kind of those measurements and what is missing there?
Yeah, I think that's going to shift a lot. So there just historically has been a lot of emphasis on the transcriptome. We're big fans of it. Our lab helped invent RNA-seq, or is one of the labs that invented RNA-seq. But there's no question that proteomics and metabolomics, because they're closer to things you can act on, will probably turn out to be more powerful. And there are many different forms, they call them proteoisoforms, forms of proteins that you don't necessarily get from the genes and the RNA and the transcripts. So I do think the protein information, the metabolite information will probably turn out to be a lot more actionable. People will definitely be more interested in that. It's just that the technology has been lagging for doing that in terms of both throughput and cost. And that's changing, as you point out. So I do see a paradigm shift. It's already happening now.
Any things you recommend or things you do that maybe the world generally doesn't know about that are sort of longevity hacks that our readers or listeners rather might be interested in trying in their own lives? This is not medical advice, I hasten to add.
Yeah, sure. So I would say, a few key things. The number one device is a continuous glucose monitor. I think everybody should wear them sooner rather than later. Not all the time, but at least wear one to see what's going on with their glucose control and modify. A smartwatch is right up there. I think everybody should have a smartwatch. Depends on your style, depends which one is best to get. And then I do a lot of the standard stuff. I take antioxidants, I take anti-inflammatories, I take beet extracts as a supplement for nitric oxide to keep my endothelial function high. So I do a lot of the standard things, and probably should put that up on a website. I never do. But so there's certain obvious. The number one thing I forgot to say that I do is I actually exercise every day. Anyone will tell you that the key to longevity is exercise. Number one, probably food number two. And I happen to be a weightlifter. You can't tell, but I'm a believer muscle mass is pretty critical for actually longevity as well. And I think now this is becoming realized by many. So I lift weights every day, light days and heavy days. So that would be probably my number one recommendation. Get out there and exercise.
Great. I think that was all for today. Professor Snyder, this was a true pleasure. Enjoy the conversation and hope to have you as a guest again.
ARC believes that the information presented is accurate and was obtained from sources that ARC believes to be reliable. However, ARC does not guarantee the accuracy or completeness of any information, and such information may be subject to change without notice from ARC. Historical results are not indications of future results. Certain of the statements contained in this podcast may be statements of future expectations and other forward-looking statements that are based on ARC's current views and assumptions and involve known and unknown risks and uncertainties that could cause actual results, performance, or events to differ materially from those expressed or implied in such statements.